All right, here we go, your factoring review. With this checklist today, we want to make sure that you move through each of these tasks and catch up on whatever work you did or did not get to finish during the rest of the week. All right, so when you took your test on Monday or Tuesday, you had a factoring review worksheet that looked like this. And what we want you to do is watch that video, check your answers, and answer these two reflection questions. The Factoring Review 2 worksheet was the one that started off with these number puzzles, and we talked about the difference between multiplying, and we talked about the difference between what it means to factor. You tried to do a few, and I set you up on your own, and we'll provide this answer key when I see you next. So for this one, watching that video key, you're still going to have to do, you're still going to have to check back in. All right, so today we're going to talk about and bring together what are these polynomials, what are the special patterns, and what it is that you're doing. You're going to continue talking about looking at factoring, and after you finish your polynomials review worksheet, we have 3 practice levels for you to work on, 3 puzzles for you to answer. For level 1, you're going to answer the did you hear about? For level 2, you're going to find out what happens if the Jolly Green Giant steps on your house. And for number 3, why didn't Klutz do any homework on Saturday? These are the puzzles we love to hate to love. The jokes are pretty bad, but they make all of that practice that's necessary a little bit more fun. All right, so let's dive in with our polynomials review. We're going to back it up a little bit and talk about what is a polynomial. Why do we care? Why does it matter? All right, we can classify polynomials in 2 ways, by looking at their degree and their numbers of terms. If I have a monomial, that's 1 term. A binomial is 2 terms. A trinomial is 3 terms. And a polynomial is going to be anything that is greater than 3 terms. So a monomial can be as simple as 2x. Now I know you're thinking, wait a minute, I see 2 values here. This is a coefficient. So when we're talking about what we mean by the number of terms, we can talk about terms are things that are added or subtracted. So this is a binomial with 2 terms. This is a monomial with 1 term. When we talk about a trinomial, that's going to have 3 terms. So if I had an x cubed plus 2x minus x, this is a trinomial, 1, 2, 3 terms, and it's a cubic because my x is to the 3rd power. This is quadratic because my x is to the 2nd power. This is linear because my x is to the 1st power. Note, we don't write the 1st power, it's understood. If I have a polynomial, it can have coefficients or not. Typically, we write our polynomials in descending order. 4th power, 3rd power, no 2nd power term, but 1st power. And this constant here, we say, is a variable with a power equal to 0. Anything to the 0 power is equal to 1. Therefore, when I have a constant, we understand that that is x to the 0 power. Standard form of a polynomial is going to have our terms listing in descending order from highest to lowest power. All right, so what we ask for you is to give an example of each of these using the vocabulary above. Let's see how you do. All right, let's see how you did. Now, of course, any of these answers can have multiple different choices. So obviously we're not going to match, but let's see. Do you have 3 terms? Because your terms are separated by addition or subtraction signs. So check and see if yours has 3 terms. If it's quadratic, check and make sure that your highest power is a 2, and that is your first term. That's a quadratic trinomial. A linear monomial means I have x to the first power and I just have 1 term. So no addition or subtraction signs. If I have a quadratic, I have a 2. If I have a binomial, I have 2 terms. These are separated by the subtraction sign. If it's cubic, my highest power is a 3. If it's a polynomial, I have greater than 3 terms. So I have 4 terms for that one. When we talk about polynomials, polynomials can be added, subtracted, multiplied, or divided. When we add and subtract, there's 2 different ways we can do it. We can stack and match up like terms. Like terms are going to be terms that have the same powers of x. So if I wanted to add these 2 polynomials together, I can line up my quadratic terms, my linear terms, and my constants. When I add them together, if they cancel out, then they just become a 0. And then 1x squared plus 4 more x squares is 5x squared. So this written in simplified terms is going to be 5x squared minus 2x. Be very careful of your subtraction sign, because what this means is I'm taking this whole value away. I'm subtracting this entire thing. So this negative sign has to be distributed to the entire expression. So when I look at what it is I'm adding here, I have 5x cubed plus 3x squared minus 7x plus 10 minus 3x cubed minus negative, meaning plus, minus a positive, meaning minus, minus a negative, meaning plus. When I do a string of terms added together, it helps me to cross off terms. So here's my cubic terms, and when I add my coefficients, I wind up with 2x cubes. 3x squared plus 1x squared is going to be 4x squared. Cross them out. Negative 7x's, take away 4 more. Gives me negative 11x's. Positive 10, positive 1 gives me positive 11. I've combined all my like terms by carefully looking at and finding the sums or differences of my coefficients. All right. When we multiply expressions, we're going to use the distributive property, and that distributive property, our first, outer, inner, last FOIL can help us. Now we don't need that here or here, because when we multiply this out, we don't have an algebraic expression here. 2m's times 3m's is 6m squared. 2m's times negative 2 is minus 4m's. This 3x is shared to each term. Minus 9x cubed plus 6x squared minus 3x's. I only need FOIL when I have 2 algebraic expressions multiplied by each other. These are each binomials. If I have a monomial coefficient, that's easy to use my distributive property. If I have a plus sign and a plus sign, that means that I have to distribute each term to each term. So my first terms, x times x, x squared. My outside terms, x times negative 7, my inside terms 4 times x, and my last terms negative 28. Frequently your middle terms will be able to be combined. So I can say x squared minus 3x's minus 28. Go ahead and try these 6 and come back and check your work. All right, let's see how you did. So I'm going to make sure that I multiply my first terms, my outside terms, my inside terms, my last terms. 10x's and 3x's combined give me 13x's. Positive 3x's, negative 2x's combined, positive 1x. Now this one's interesting because I had a squared. When I go ahead and I distribute, I don't end up with a middle term that I can combine. So instead of having a trinomial answer, I just have a polynomial, a 4-termed expression, because these are not like terms and cannot be combined. The opposite happens here, where I end up with a 0 pair. Minus 2x squared plus 2x squared. They're a 0 pair and cancel out. So I end up with x to the 4th minus 4. Keep in mind x squared times x squared is x to the 4th. These are the tricky ones we need to be careful about. Make sure that you write it out. 3m minus 2 times 3m minus 2, that's what it means to be squared, this double factor. If you're not careful, you'll miss out on this middle term. Now this one's tricky. I have a binomial times a 1, 2, 3 trinomial, which means I have to multiply each term by the other terms. So 2x times 4x squared, 2x times negative 5x, and 2x times negative 6. Then I have to distribute this negative 1. Negative 4x squared, positive 5x, positive 6. Then I go through and I combine my terms. 8x cubed, and then I combine my minus 10x squareds and my minus 4x squareds, my minus 12x's, my positive 5x's, and then my constants. How did you do? All right, so if we flip over to the back, we're reminded that factoring is the opposite of multiplying. You're breaking down that polynomial into the expressions that were multiplied together. So you're going to be unfoiling the expressions. Now keep in mind some polynomials are prime and cannot be factored. And remember we talked about it's always best to look for that GCF, that common factor that can be divided from each term. So let's go ahead and jump right into this one. I have a 24a squared. I have an a here and I have an a here. Uh-oh. Boy, this one's tricky. So it looks like I can take a 4 out of each, and that's going to leave me with a 6a squared plus 2b squareds. ab squareds. And then I'm going to have minus 3ab's, and then I'm going to have minus b cubes. So we'll just let that one sit as it is for now. What do you think? All right, so now we're going to look at these next one, and we're going to look for our number puzzle, a sum of 7, a product of 12, and when we break down our product of 12, we're looking at a 1 and a 12, a 2 and a 6, and a 3 and a 4. There's our wraparound. Here's our sum of 7. So I know that this breaks down into x plus 3 and x plus 4. I'm still kind of stymied by this one. I wonder what we were going for there. I can't help but wonder, was this a typo? I don't know. It's bugging me and I'm thinking about it while I'm doing my next one. All right, let's keep going on the ones that are recognizable. number puzzle says a sum of -1 and a product of 20. When I break down 20 into 1 and 20, 2 and 10, 4 and 5, there's my wraparound. So if my sum is negative and my product is positive, that means I'm looking for two numbers that can be multiplied. So when I'm thinking about it, they both have to be negative, which means this has to be the sum. Guess what, guys? I think this one is prime. All right, let's check out this one. Number puzzle says a sum of -4 and a product of -21. 21 is 1 and 21 and 3 and 7. There's my wraparound, and there's my difference of 4. So I have x -7 and x +3, and here's why. My sum is negative, so I need to have more negatives than positives. That's why my 7 is negative and my 3 is going to be positive. All right, let's look at this one. Number puzzle, two numbers that add to 8 and multiply by 16. When I look at my 16, I have 1 and 16, 2 and 8, 4 and 4. There's my wraparound. Here I have two numbers that add to 8 and multiply together to be 16. So I know that it's x +4 and x +4. Let's look at this next one. I have a sum of -13 and a product that's positive. So right away I know that that's going to be an x minus, because two negatives multiply together to be a positive and two negatives add together to be a negative. All right, so if I break down 36, I'm looking at 1 and 36, 2 and 18, 3 and 12, 4 and 9. Don't forget about 6 and 6. There's my wraparound. So if I'm looking for a sum of 13, there it is. So -9 and -4. So when we go back and look at these, I don't know what the heck we were going for there. Our x squareds are going to split 1x into this polynomial, 1x into this polynomial. 3 and 4 have a sum of 7 and a product of 12. There are no numbers that multiply together to give me a product of positive 20 and a sum of -1. If I had a product that was negative, we could mess around with the difference between 4 and 5, but we're going to call this one prime. My x squareds split. A product of negative means I have one negative and one positive value. Because my difference is negative, that means I had more negatives to start with. This one is interesting because I can rewrite this as a perfect square. In fact, we're going to start looking at some of these special patterns when it comes to factoring. If I have the difference of two perfect squares, you'll notice in here I have no middle term. This middle term is the one that is the sum. And if I look at where that might have happened, that is because I have a middle term of 0. Because my product is negative, I know that this sum had to have been a positive and a negative of the same number. Whenever you see a difference of two perfect squares, you know that that comes from a sum and a difference of the square root of that number. So think about it. My first terms multiply together to be x squared. My outside and inside terms are going to be a 0 pair. Negative 12x, positive 12x. that adds together to be 0. Positive 12, negative 12 multiplied together to be that negative. When we look here, a difference of two perfect squares, my x's split. I know my signs are different. And when I look at what is the square root of 25, I know that positive 5 and negative 5 were what multiplied together to give me that value of negative 25. I had a sum of 0 and a product of 25. Negative. When I take my 7 out, this people seem to forget is that perfect square. So my 7 stays, and then I end up with my two binomial expressions. X times x is x squared. A positive and a negative give me a negative product. 1 and 1 give me a sum of 0. What's kind of cool with some of these is we can also play with the fact that if this is a perfect square, even if it has a coefficient, I know it's going to split evenly. So 4x squared, 2x, 2x. Plus 5, minus 5. Don't forget about your GCF. 4x comes out of both. That's going to leave me x minus 4. Hey, guess what? This counts as factored. Our goal in factoring is to break x down so it's to the first power. Once I reach this, I have found my two things multiplied together, so I don't need to do anything else. Be careful of this one. There's no x there. This is x squared plus 35. This cannot be factored. We're going to call this one prime. Now this is an interesting one because it breaks down, and these next three determine our other special pattern. If we have the difference of two perfect squares, we get a sum difference. We're going to call this one the square double square because each of these values is a perfect square. When I'm looking at a sum of negative 18 and a product of 81, those values that complete that number puzzle are the same. So minus 9 gives me x minus 9 squared. Here's a square, here's a double, and here's a square. So if I go to look for what two numbers add together to be 12 and multiply together to be 36, sounds like two negative 6's. X minus 6 squared. It's not only with negative values, but also with positive. So we can see our square, we can see our double, and we can see our square. We're going to end up with x plus 10 squared. All right, here are some for you to try on your own. Pause the video and check your answers. All right, pause the video. I hope you did. Check your answers. So some of these are very, very tricky. We'll see. We won't give you ones these hard out of the gate, but what a good challenge for you. Here's a square, double square pattern. Anytime you have the sum of two squares, that's going to be prime. This one's straightforward. 9 plus 4 is 13. Here's my sum. Here's my product. Here we have a negative product, positive negative. Here we have a positive product. That's why it's a negative negative. Positive product, negative sum, negative negative. This one is a tricky one. I'm not sure where this one came from. We're going to call him prime. This one was super tricky because you can look and see that this 7 and 8 is going to give me negative 7ab. And, I need one of these to be positive. There we go. We like that better. And positive 8ab, and that's going to give me 1ab left over and negative b squared. So this one was the super challenge. Here, did you remember to factor out your common factor? And then that factored out. All right, here's what's next for you. When you're looking at your no more excuses, it's time to review factoring sheet. It's time for the levels. So good luck.